Has the United States just shattered the sound barrier without shattering the peace? After several years of determined development, the US has unveiled the world's first quiet supersonic aircraft, the X-59. The X-59 represents a monumental leap forward in aviation technology. This groundbreaking aircraft, developed by NASA in collaboration with Lockheed Martin, promises to bring back supersonic commercial flights without the disruptive sonic booms that have long plagued such endeavors. The innovative design of the X-59 incorporates a slender fuselage and unique engine placement to minimize the sonic boom to a mere thump. This quiet supersonic technology, QueSST, could revolutionize air travel, making it possible to fly over populated areas without causing noise disturbances. Join us as we delve into the features and capabilities of the X-59. We'll explore how this supersonic marvel is set to change the landscape of aviation forever, from its technical specifications to the broader implications of its quiet supersonic flight. Breaking barriers. Speed is the name of the game when it comes to military aviation, but with speed comes the controversial phenomenon of the sonic boom. Supersonic aircraft, upon exceeding the speed of sound, generate shock waves that merge into a loud, disruptive noise, causing significant challenges for supersonic travel, especially over land. Remember the Concorde? This iconic supersonic passenger jet, developed by France and the UK, promised flights from New York to London in just 3.5 hours. But as thrilling as its debut in 1969 was, the excitement quickly waned when the Concorde's thunderous sonic boom, akin to a bomb explosion, shattered windows and rattled doors. The powerful engines produced a sonic boom with a pressure of about 2.2 pounds per square foot, leading many countries to ban supersonic flights over land. The FAA's restrictions in the US, established in 1971 and globally adopted in 1973, further stymied the growth of supersonic travel. However, a groundbreaking initiative began in 2016 when NASA challenged Lockheed Martin and other companies to design a test aircraft capable of safe and silent supersonic flight over land. The ambitious goal was to create a plane with a sonic boom perceived at just 75 dBA, equivalent to a dishwasher's hum for less than a second, compared to the Concorde's ear-splitting 105 dBA. By 2018, Lockheed Martin received a $247.5 million contract to develop this quiet supersonic jet, the X-59 QueSST. Construction started promptly in Palmdale, California, and major structural components were assembled by mid-2019. Initially set for flight tests in 2021, the project faced delays but is now scheduled for NASA testing in 2024. The X-59 aims to fly at Mach 1.42 and 55,000 feet, producing minimal noise, just 75 dBA. To ensure the X-59's success, it will undergo extensive tests, including flying over 6 US neighborhoods to gauge public reaction. The ultimate goal? To make supersonic flight over land acceptable and revolutionize current regulations. Recently, the installation of a powerful General Electric F-414 GE100 engine used in the US Navy's FA-18 Super Hornet marked a significant milestone, positioning the X-59 for imminent flight tests. Weighing in below anticipated levels, the X-59, about 100 feet long with a sleek design to reduce sonic booms, promises to be much quieter than the Concorde. Quiet Supersonic Jet. Back in August 2023, the X-59 made a brief appearance in front of cameras, but now, with its stunning red, white, and blue livery, it's ready to take the spotlight. According to NASA Deputy Administrator Pam Melroy, this major accomplishment showcases the hard work and ingenuity of the entire X-59 team. From a mere concept to a tangible reality in just a few short years, this supersonic marvel promises to revolutionize travel, bringing us closer together in much less time. Lockheed Martin highlights the X-59's potential to revolutionize various fields, from rapid medical response and shorter shipping times to, of course, faster travel. The unveiling on January 12th was met with applause and a sea of mobile phones capturing the jet's gleaming form under stage lights. The X-59's striking geometry, including its sharp, elongated, beak-like nose section, was on full display, designed to shape shockwaves during flight. In a 2021 statement, NASA revealed that the unique nose section means pilots can't see out of the jet's forward windscreen because it doesn't have one. Instead, pilots rely on NASA's External Vision System, XVS, which uses a forward-facing camera, a cockpit-mounted display screen, and custom image processing software to create an augmented reality view of the pilot's forward line of sight, complete with graphical flight data overlays. While the unveiling of the X-59 is thrilling, it's only the beginning for this supersonic marvel. Catherine Bayham, manager of NASA's low-boom flight demonstrator project and development lead on the X-59, emphasizes that the rollout marks a major accomplishment, but also sets the stage for the next milestone, the first flight and subsequent supersonic flights. The X-59 team is now focused on the next steps in preparation for its maiden voyage, including integrated systems testing, engine runs, and taxi testing. NASA's X-59 takes flight. Originally, the X-59's first flight was slated for last year. However, in October, NASA officials postponed the inaugural flight to 2024 due to several technical challenges encountered throughout 2023. These included intermittent issues with some of the safety redundant computers. The team at QueSST will carry out numerous flight tests at Skunk Works before moving the aircraft to NASA's Armstrong Flight Research Center in Edwards, California, which will serve as its operational base. The real test begins when the X-59 flies over 6 residential communities across the U.S. These locations have been carefully selected to provide a diverse mix of geographic and atmospheric conditions. NASA plans to engage with these communities to gauge their response to the noise, aiming to prove that a 75 perceived loudness in decibels will be acceptable. The data collected will be presented to the U.S. Federal Aviation Administration and international regulators, potentially leading to a seismic shift in aviation regulations. Should regulations change, the skies could open up for a new generation of supersonic aircraft, allowing routes that are currently off limits, like New York to Los Angeles, cutting flight times in half. However, the design and builders of these future aircraft remain uncertain. The X-59 is not a prototype, but a technology demonstrator, providing a foundation for companies like Hermes, Boom, and Spike, which are all racing to develop supersonic passenger aircraft within the next decade. To understand the monumental leap the X-59 represents, let's compare it to the legendary Concorde, the first supersonic commercial aircraft. The Concorde was a marvel of its time with its tailless design, narrow body, and capacity for 92 to 128 passengers. Its distinctive curved delta-shaped wing and a nose that could tilt downwards for better visibility during landings were iconic. Powered by 4 Rolls-Royce Olympus turbojet engines with adjustable air intakes, it could reach speeds of Mach 2.04 and maintain them at altitudes of 60,000 feet. Air France and British Airways were the only airlines to operate the Concorde, with a combined fleet of 20 aircraft. Despite its ability to drastically reduce travel times, the loud sonic booms restricted its routes to mostly overwater flights to avoid disturbing populated areas. The return of supersonic travel. Supersonic travel is making a daring comeback, and it's sparking quite the controversy. The Concorde, despite its competition from the Tupolev Tu-144, faced a tragic crash in 2000, leading to a temporary halt in flights until safety improvements were made. Ultimately, the Concorde was retired in 2003 after 27 years of service, with most of its fleet preserved in museums worldwide. But the story doesn't end there. Advancements in materials, engine design, and aerodynamics, seen in projects like NASA's X-59, promise to develop new supersonic aircraft that meet modern safety and environmental standards. These innovations aim to revive and advance supersonic air travel, potentially offering faster and more efficient transportation options in the future. One notable technology is the North American aviation XB-70 Valkyrie, a retired prototype of a proposed nuclear-armed supersonic strategic bomber for the United States Air Force. Designed in the late 1950s, this six-engine delta-wing aircraft could cruise at speeds exceeding Mach 3 at 70,000 feet, making it nearly immune to interceptors. However, the introduction of Soviet surface-to-air missiles and the rise of intercontinental ballistic missiles led to the cancellation of the B-70 program in 1961. Two prototype XB-70. As were built for supersonic test flights from 1964 to 1969. One crashed in 1966, but the surviving Valkyrie is now housed at the National Museum of the United States Air Force. Despite its shortcomings, the Valkyrie featured impressive designs, including compression lift technology and advanced materials. In contrast, the Spike S-512 represents a modern take on supersonic travel. Designed by Spike Aerospace, this supersonic business jet will feature advanced cameras instead of windows, displaying panoramic views on curved screens inside the cabin. Initially planned for a 2018 launch, the project has faced delays, but the company remains focused on developing an 18-seat version. The Spike S-512 is designed to reach a maximum speed of Mach 1.8 with a range of 6,200 nautical miles. This innovative aircraft promises to drastically reduce travel times while offering a sleek, technologically advanced flying experience for business and private jet travelers. Thanks for watching. Click the link on your screen to check out another of our videos. See you there.